Okay, so we are going to discuss solving plane areas by polar coordinates. So the formula that we are going to use here, that is equal to area is equal to 1/2 the integral of r squared d theta with lower limit of theta 1, upper limit theta 2. So as you can see in the figure, theta 1, then theta 2. Okay. So here are some area of some polar curves. So if the given is r squared is equal to k cosine 2 theta, the curve here is given as like this one, and the area is equal to k. So if the given is r squared is equal to k sine 2 theta, the area is equal to k, and the form of the graph is like this one. And then if the given is equal to r squared is equal to k cosine theta, the area is equal to 2k, and then the graph here, so the curve here is like this one. If the given is r squared, but then that is equal to k sine theta, so the graph is like this one. So area is equal to 2k. If the given is r is equal to k sine 3 theta, you will have a graph like this one. The curve is like this one. So the area is equal to 1/4 pi k square. If the given is equal to r is equal to k cosine 3 theta, the area is equal to 1/4 pi k square, and the form of the curve is like this one. Okay. If the given curve is equal to r k cosine 2 theta, the area is equal to 1/2 pi k square. The form of the curve is like this one. And then if the given is equal to r is equal to k, 1 plus cosine theta, the area is equal to 1.5 pi k square. The perimeter is equal to 2 pi a. And the graph here is like this one. Like this. If the given is equal to rk, 1 plus sine theta, the area is equal to 1.5 pi k square. Perimeter is equal to 2 pi a. And the curve here, so that is like this. If the given is equal to r is equal to 2k cosine theta, the length is equal to 2 pi k, area is equal to pi k square, and the curve is like this one. Okay. If the given is equal to r is equal to 2k sine theta, the length is equal to 2 pi k, area is equal to pi k square, and the form of the curve is like this one. Okay, we have our first example. Find the area bounded by the curve r square is equal to a square sine 2 theta. So if you are going to look at this one, this is a form of r square is equal to k cosine 2 theta, right? So therefore, the form of your curve is like this one. So we know that the curve is symmetrical with respect to the origin, and then it occurs only with values. Okay, what values this would be equal to 0. Okay, this would be equal to 0 when you will have cosine 90. Why? Because cosine 90, that is equal to 0. But then this is 2 theta, so therefore you will have a hint. What is your hint? That is 90 divided by 2, so you will have 45 degrees. So therefore, your point of interest here, that is 45 degrees. So negative 45 degrees to positive 45 degrees. Because if you will have here 45 degrees, this would become 90. Cosine 90 is 0. So you will have here, so theta, that is from 0 to 45 degrees and 0 to negative 45 degrees. So theta, then what is the value of r? If the value is 0, cosine 0 is 1, right? If 0 degrees, cosine 0 is 1, so you will have a square. The square root of a square, that is plus minus a. So this is now your a and 0. So this is now the coordinate a and 0. And then this is the length of r, that is the highest. And then you will have at 15 degrees, so 15 times 2, so 30. Cosine 30, okay, you will have cosine 30, then you will have the answer here. Cosine 30, that is 0.9306. So you will have a square, so square root of that. So that's the reason you will have 0.9306. And then cosine 30, 30 times 2, that is 60. So take note here. So take note, if you will, how to determine the special angles. So the 60, if you are going to cut this in half, so this is 30 degrees. Okay. So that is 30 degrees. So this is 1 because you cut in half. 1, this is square root of 3. So if you will have cosine 30 square root of 3 over 2. Okay, that's the value. So square root of 3 over 2, that is cosine 30. Square root of 3 over 2, then square root of, so square of that, so you will have the answer. So for 60, because if you will have 30 degrees times 2, that is 60 degrees. So cosine 60, that is 1/2. So the square root of 1 over 2, you will have this answer. And then you will have 45 times 2, that is 90. Cosine 90, that is 0. So that's the reason you will have answer of 0 here. So any values above 45 degrees, you will have an answer of negative, that is imaginary. So here, this explanation here, the curve is symmetrical with respect to the origin and occurs only with values of theta from negative 45 to 45 degrees, or negative pi over 4 to pi over 4. So the area by polar coordinates, you will have area is equal to 1/2 r squared d theta. And then since you have two areas, enclosed areas here, that's the reason you multiply with 2. So multiply with 2. And then r squared, that is equivalent to a square cosine 2 theta. So a square cosine 2 theta. If you are going to look at here, you have only one trigonometric function. If you have only one trigonometric function, so therefore you are going to have u as your 2 theta. U is equal to 2 theta. Du is equal to 2d theta. So you multiply 2 to your d theta. So multiply 1/2 outside. So that's the reason you will have 4 over 2 times 1/2. So cancelled out. What is being left is a square. The integral of cosine 2 theta, that is sine 2 theta, evaluated from 0 to pi over 4. Sine pi over 2 minus sine 0. So your answer here is sine pi over 2, that is 1. So that's the reason you will have area as a square. So that's it. The next example, what is the area within the curve r squared is equal to 16 cosine theta? Okay, we will look for when you will have an answer of 0. So that is cosine. So cosine 0, that is 1. So therefore cosine 90, you will have 0. So therefore that starts with negative 90 to positive 90, right? So you start with 0 degrees, then you will have 30 degrees, 60 degrees. So greater than 90 degrees, that is imaginary. So you will have now the table. What is important is your limits. So to find for the limits, that is the condition wherein you will have a zero answer. So that can be your basis, because that will have, you will have now the closed form of your curve. So the values in the table shows that the graph is symmetrical to the origin, and theta ranges from negative 90 to positive 90. So area here. So area. So if we are going to start our lower limit from 0 to 90 degrees, 0 to 90 degrees, meaning we cut the first area into half. So that's the reason you will have 0 to 90 degrees, 1 half r squared d theta. But then you are going to multiply outside with 4. Why 4? Because we take only 1 half of the first area. And you have 2 areas. And we take only 1 half. So that's the reason you multiply with 4. So you will r squared, that is equal to 16 cosine theta. So u is equal to theta, du is equal to d theta. So the integral of cosine, that is positive sine theta, evaluated from 0 to 90 degrees. Sine 0, that is 1. Sine 0, that is 0. So therefore, you will have an answer of 32 square units. Okay, that's it.